In this video, we'll be exploring graphs of even functions that are also quadratic functions. What is an even function? First, think of an even number of objects and how they can be arranged. No matter how you arrange them, they can be split into two equal groups. You don't often think of even-numbered items as having symmetry, but here's an example. This group of 12 items can be split into two groups of 6 that have a line of symmetry like this. Remember this symmetry as we look at even functions. An even function has this property. Suppose that f of x is an even function. This means that f of x equals f of negative x. Graphically, this means that these points on a graph are mirror images of each other across the y-axis. Let's explore this on Desmos. Launch a new Desmos window. You may want to log in. Input the coordinates 1, 1 and click on Label. 1, 1 and click on Label. And you see the point here. Then graph negative 1, 1. Negative 1, 1 and click on Label. These 2 points are mirror images of each other across the y-axis. Next, graph a quadratic function that crosses these points that also starts at the origin. So input this function, f of x equals x squared. F of x equals x squared. You can see that f of x intersects both of these points. Let's replace the coordinates with a placeholder variable. Replace 1 with b, like this. You'll be asked if you want to create a slider for b. You do, so click the blue button. Replace the y-coordinate with f of b. Repeat this with the other point. Input negative b and f of negative b. Now change the slider and see what happens to the points. As you can see, as you change the value of b, the coordinates change, but one thing stays the same. They are mirror images of each other across the y-axis. This demonstrates that this parabola is an even function. We can generalize this. Change f of x to include a coefficient a. F of x equals ax squared. Create a slider for it. Change the values for a to change the width and orientation of the parabola. No matter the width and orientation, the 2 points are mirror images of each other across the y-axis. The parabola remains an even function. We can even generalize this further. Add another variable, c, next to the quadratic term, like this, ax squared plus c, and create a slider for c. Click and drag on the slider and see the effect on the graph. The vertical placement of the graph changes, but it remains an even function. In fact, if you animate sliders a and c, you can create an endless number of quadratic functions that are even functions.